squared plus that thing squared dx dt dy dt. Then we'll get integral from 0 to 2 pi square root of 4 sine squared 2t plus 4 cosine squared 2t. Sorry, it's not 2t, it's tt, which is 2t dt. Okay, so this will give us 2 times 0 to 2 pi square root of 1 dt, which is 4 pi. And you can see the maximum, like the circumference of the circle will be just 2 pi, but in this case we have 4 pi. So this means that the curve traces out the circle twice. So we'll eventually get twice the circumference of the circle as our answer. So it is definitely not arc length of any circle. Okay. So after that, let's move on to the actual free response question from 2015 AP Calc BC exam. So we have the question. At time t greater than or equals 0, a particle moving along a curve in xy plane has a position xt, yt with velocity vector vt equals cosine t squared and e to the negative 0.5t. At t equals 1, the particle is at a 0.35. So the problem A is to find the x-coordinate of the position of the particle at time t equals 2. And for 0 smaller than t smaller than 1, there's a point on the curve at which the line is tangent to the curve has a slope of 2. So at what time is the object at that point? And C, find the time at which the speed of the particle is 3. And the last one is to find the total distance traveled by the particle from time t equals 0 to t equals 1. So using your knowledge from the calculus, you can pause the video to solve the problem, and then we'll discuss it together. Okay, so now let's go over it together. So for question A, it says find the x-coordinate of the position of the particle at time t equals 2. So since this is the x-coordinate of the velocity, and it asks for the position of the particle, and we know that at t equals 1, the particle is at 0.35, so we know that the x-coordinate at t equals 0 is 3. So we'll have 3 plus something. So the something is the integral of cosine t squared from 1 to 2, right? Because it goes from t equals 1 to t equals 2. And then we'll find the position of the particle at time t equals 2 overall, plus the t equals 1 where the x coordinate is 3. Okay, so what we're going to do here is just to plus the integral from 1 to 2 cosine t squared dt. And since you can use the calculator for this problem, when you use the math 9 command, you'll eventually get 2.557 or 556. Okay, so this is the question A. And question B, it says there's a point on a curve at which the line tangent to the curve has a slope of 2 for the parameter interval 0 and 1. So what time is the object at that point? So first let's look for the dy dx in this case. So dy dx will be, because we already have dy dt and dx dt, so dy dx would just be e to the 0.5t over cosine t squared. And this has a slope of 2, so the slope will be 2. And then eventually you'll get t equals 0.84, because you can use a calculator. You can plug this into a calculator and solve the equation. And for C, It says find the time at which the speed of the particle is 3. So the speed will be using Pythagorean theorem. Just use the x and y coordinate. We have the speed equals square root of cosine squared t squared plus e to the t power equals 3. Because the speed of a particle is 3. And then eventually when you solve the equation in the calculator, you will get t equals 2.196 or 195 as the answer for part C. And then part D, you need to find the total distance traveled by the particle from time t equals 0 to t equals 1. So the distance will be just because we know that the overall speed of the particle is defined by this. So distance will be the integral of this. So in this case it says when the particle is moving from time t equals 1 to t equals 0, so we are basically looking for the integral from 0 to 1, and then plug in this. We have integral from 0 to 1 cosine squared t squared plus e to the t dt. So when you use the math 9 command, you'll eventually get 1.595. Okay, so that wraps it up. That's all you need to know for the parametric equations when you are practicing AP Calculus BC problems. So I hope you have got more familiar with the topic. So thank you for watching the video, and see ya.